Test. Okay. We're live, yeah? Good. Good morning, everyone. We're going to get started here, but first I want to welcome everyone to the Vancouver Summit here, and it's sponsored by Heumaus as our event sponsor, so thank you, Heumaus. I'd also like to thank the other sponsors, our venue sponsors, GrowWatt, Pylon Tech, our networking sponsors, Longi and Fronius. We will also, I want to mention that this event is being live streamed on YouTube, so we'll have some people watching in from there as well. There's one change to the agenda, just a slight one. Unfortunately, Zach from GrowWatt couldn't be here today, so Alex and myself will jump in and do that presentation on his behalf. With that said, I'd like to invite Hazine up here to introduce our first speaker.
Yay. Oh, thank you. Give me 1 second. Okay. Hi, everyone. My name is Hazine. I am the marketing coordinator for Frankensolar. So just to get this presentation started, for our first presentation, if you guys have checked out our agenda, we will be joined by Alexander Wolf, the product and solutions engineer here at Frankensolar. He's going to be giving us some insight on battery systems and new certification requirements for UL 9540 and UL 9540A. For those of you that haven't gotten the chance to meet Alex in person, so like I said before, he is our product and solutions engineer. He specializes in power electronics and has worked as a hardware developer for three-phase commercial string inverters and designs. Alex is an expert within the solar industry with firsthand experience, which allows him to develop customer-specific and innovative system solutions. So for now, I'd like to give a warm welcome to Alexander Wolf.
Good morning, everyone, also from my side. There it is. Perfect. A very hot topic these days. Lots of people are looking into battery storage systems. And with the new Canadian Electrical Code in 2021 that for most provinces came into effect on January 1st this year, things got really, really complicated, and a lot of people are not very familiar where all those new requirements come from and how you can actually install systems under the new code and under some variance options and deviation requests for certain provinces. So my presentation today is about the understanding of UL 9540 and the UL 9540A, and we will dive a little bit deeper into how it works. Haseen, I cannot move forward with my... There you go. Here it is, exactly. A quick presentation overview. We want to learn about the system certification. That's the high-level certification that covers pretty much the entire system. We will also look into what goes into the actual battery fire propagation testing. That's the underlying UL 9540A. And then the technical issues, as I mentioned, that are really coming from the new CEC code, and maybe an outlook what will be coming in the 2024 CEC. The second part of the presentation is really that that code that we have today. What does the 64918, that's the most critical part of the new section 900 in the electrical code, say? What are the options that we have to still install in residential dwellings those battery systems? And then a quick overview, what's actually available on the Canadian market, what certifications and what labeling the products that are available have, and how can you go through certain product options that you can actually install. Jumping right into the UL 9540 overview, it's pretty much a safety standard for battery storage or energy storage system in general. It's all about safety, that this storage system in your residential home does not go up in flames, or if the building has a fire, that you're not adding more risk to that building fire. The very good news is here that it's almost the first code now. We have a binational code. So in the past, we have the UL for the US market, and we have the CSA certification for the Canadian market, and they were sort of similar, but not the same. Now with a binational, a harmonized code, we now have a testing requirement that is identical, no matter if you want to bring that product into the US market or into the Canadian market, which makes it a lot more interesting for manufacturers to come to the market and have something that works for both countries. Previously, most manufacturers focus on the US market because it's just the much, much larger market, and Canada is more like an afterthought. Now, with that binational code, they can still focus on the US market, but the Canadian customers in the Canadian market has the same requirements and gets the same product offers that the US customers get. And then the energy storage systems are typically intended for grid-tied systems with a standby application for backup or an arbitrage. We will talk about that a little bit later. Typically, the system certification has multiple categories. We have typically the indoor category for non-residential, let's say commercial applications or dedicated buildings like an e-house. We have complete outdoor systems that are in a special outdoor cabinet that you put outside of the building in regards to fire code and local requirements. Then we have special applications, which we don't want to talk about because that is, for example, for New York State. They have rooftop battery storage systems, or battery storage systems in parking garages to support EV charging. And then the focus we want to do today is the residential, because that's the most critical under that CEC 64900. The UL 9540, as I mentioned, is a system certification. So it's no longer just a certification of one component and then another component and then another component on their own. Like, for example, a solar system, you have the certification for the solar inverter. The solar panels have their own certification, and your racking system has a totally different certification for the grounding and whatnot. Now you bring that all together and form a system, and you have one certification that pretty much certifies the function between those components in that system. So for the inverter, for example, it's the UL 7041, which a lot of people already know. It's a hot topic also with the SB certification that is required specifically in Alberta and the Western Canadian market. The battery typically has their own certification for the battery cells and the battery module and its fire propagation testing. And if you wrap that system up with a transfer switch, can be a partial home or full home backup, that transfer switch has also certification. But together, that system will be a UL 9540 certified system. And that's very important because that is a relatively new thing. With that new harmonized code, so the CAN for the Canadian market, the UL for the US market, the 9540 to the 2020 version, which is the newest one, which is now required under CEC 2021. We no longer talk about individual components. We always talk about the entire system. At the end of the day, coming back to my first statement, it's all about safety. So how can a certification identify probable or issues that can arise from the combination of a certain battery chemistry, a certain battery module, the size of the system, and the certification body, that can be pretty much any lab, UL, TUV, CSA, Intertech, and whoever it is. They can then identify what kind of hazard that system will present to the home or the application, a risk analysis, a risk evaluation, and very important, a failure mode analysis. So they think about, okay, what can go wrong with that system and what could be the outcome of that fault to a house fire, for example, or the risk to people. Exactly. It's not only the technical safety part that is covered under that new certification. The certification also requires certain documentation requirements. So the manual, how you install a system, how you install the different components, sometimes from different manufacturers together as a system, and what setbacks, for example, you have. That's the separation distances, depending on how big your system will be or how large. And if there are some protection elements that need to be added to the system in order to make it code compliant. Like commercial systems, for example, have some fire suppression systems or some explosion vent systems. And at the end of the day, you also have to deliver to your inspector the actual documentation, what went into that system certification. So, for example, if you use a battery system, for example, from Pylontech, Pylontech has specific documentation for the UL 9540A, the fire propagation testing. And if you issue all the documentation to your inspector with a certification document, that is part of that overall certification. So the fire testing standard, and I have on top here always the code we're referring to, because we refer to quite a few different codes and testing standards. So in this case, the UL 9540 with the A at the end is the fire propagation testing that is required to actually do the higher level system certification to the UL 9540 without the A. It's pretty much the methodology of testing a battery technology when it goes into a thermal runaway. That's typically the case for a lithium-ion chemistry. And evaluate what is happening to a fire and the explosion hazard options to that system when it goes under that thermal runaway. The test is characterized in 4 different levels. And we have the lowest level, which is the actual cell itself. Then the next level is if you put multiple cells into a battery module. Then you can have multiple battery modules in a unit. And if you have very large-scale systems, like a containerized battery storage systems, then we talk about the installation level, where pretty much all these components, including fire suppression systems and whatever, will be put into a system, and then it will be tested and inspected to that highest level in the installation itself. At the end of the testing, you will not get a testing certification for that. You get a testing result. So the testing lab shows, okay, we did all these tests with all the thermal impacts, and we state, okay, this was the outcome. And then you may or may not meet certain criteria to that cell level, and we go about those, or we look into that in a second. The most critical part for lithium-ion chemistries doesn't really matter which specific chemistry, if that's a lithium iron phosphate or if it's a NMC or NMA, like more from the automotive industry. Every lithium-ion chemistry today that's on the market has a thermal runaway at one point, meaning that you have a very sharp increase of the temperature and then, of course, a certain chemical release and heat release to the environment. That is pretty much your fire or your smoke that gets out of the cell. The first on the cell level is, can the cell go into thermal runaway? And the answer is, for lithium, as I mentioned, yes, it will, because we just start heating at about 7 degrees per minute. And at one point, at a few hundred degrees here, the cell starts to vent. And a little bit later, all of a sudden, the cell completely goes into thermal runaway and pretty much is releasing its energy. The testing will then see, okay, what is the actual venting temperature when that smoke or the gases are being released. And then it will collect data about what is actually being released and how flammable are those chemicals and that gas that is being released in that system. So at every level, the cell, the module, the unit, and the installation, you will have a certain performance criteria. And if you pass that, then you don't have to go to the next level. So the best solution would be in the industry, which is not the case right now, if a manufacturer can pass on the cell level, they don't have to do the unit and the module and all of that afterwards, because they're already super safe on the smallest increment that represents the risk in that system. And if there's no thermal runaway observed, and if there's no flammable gas, then it's pretty much a toaster in your household. There's no inherent risk coming from a toaster, and you can plug in and operate that toaster anywhere in your household. It can be in the basement, it can be in your kitchen, it can be in your bedroom. The code doesn't restrict anything where you put that system. Go ahead, Harsha.
You mentioned UL 9540A
Yep.
is not a certificate.
Yeah.
So if you can pass at least the most critical safety test here, what can you claim to be certified to?
Exactly. So then you take that UL 9540A fire propagation test, and you said you passed the performance criteria on the cell level. And then you go to your certificate, as a manufacturer, of course, to your certification body, let's say CSA or UL, whoever that is. And then you do the UL 9540 test. And since you already passed at the lowest level, at the best scenario possible, then you have a breeze going through the certification, because you are super safe as it can be. But unfortunately, that does not exist currently in the industry. So most manufacturers have to go to the next level, which is the module level test. So now you put multiple of those cells that could have a thermal runaway in a enclosure or a module. That can be a 19-inch module, like multiple manufacturers, or it can be a different enclosure, like a stacked battery system with the enclosure already tied into it. And then the whole thing starts again. The lab tests, okay, when is it going into a thermal runaway? What happens to the thermal runaway if one cell, so you start heating one cell and see what happens to all the other cells in that cabinet. And by designing the cabinet in a certain way, the manufacturer of that battery module can contain the problem into that single module, and the risk is not spreading to other modules in that stack. So you're just limiting your exposure of risk. For example, you cannot have any flaming outside of that module. You cannot have a certain heat release, so it cannot be extremely hot what the module is radiating to it. There's also a chemical release or heat release rate where certain chemicals are being released that cannot or should not go up in flames. The smoke needs to be limited to a certain amount of volume over a certain amount of time, and the whole thing cannot explode. Once you have contained all those risks, then you can pass the performance criteria on the module level. And that's what most manufacturers today having their system tested to and pass on that level. On the right side here, we have, for example, one of those setups in a lab from, in this case, a Pylon-Tech battery. And we have the observations during the test. And there is some smoke being released after it was heated up. There was no flying debris and no explosive discharge, so we passed that one. There was no flame, no sparks, no electrical arcs, and no other electrical events after that test, so perfect. And then after the tests, there was no propagation inside the module, meaning that that cell that was heated and went into thermal runaway did not ignite or contributed to the thermal runaway of other cells that are right beside in that module. Electrolyte, of course, can be released, so the whole thing will look very ugly, but at that point you already had a damaged system, and pretty much all the risk was contained in that module. At that point you have to replace that module at least, or maybe multiple modules depending on how messy that problem was. And if you have that, that's similar to a stove in your household. So you also have restrictions, some code requirements where you put a typical stove, because it's very, very similar. You have to vent that. It has to have some setbacks. And once you consider all these things, you can install a stove in your household. On the unit level, it's pretty much then the next level up from the module. Similar to the module, but now just on a bigger system. You can still not have any flaming outside the actual unit. So, for example, you have a battery cabinet. The surface temperature to other systems. So, for example, if you have one battery cabinet or multiple battery cabinets, if an incident happens to one battery cabinet, it cannot propagate to the next battery cabinet if it's a bigger system. For example, a large 40 kilowatt hour or maybe even 80 kilowatt hour system, according to code, that cannot go over to other systems. And the radiation, the heat radiation from that system to walls or the environment, that walls beside it cannot exceed a certain temperature, that you're not igniting, for example, some studs in your basement or in your room that are wooden, and nothing is going up in flames there. And you cannot have any explosion or accumulating of gases that can then lead to an explosion afterwards. That's also the last element, that the flammable gases needs to be below a certain level. For outdoor systems, it's pretty much the same, but you have different separation requirements if the manufacturer has an issue with his design, that flames are actually observed. And then, of course, it cannot be put in a building. The commercial, the installation level for commercial, that's pretty much for large-scale system only. We don't want to go too deep into it. You have a whole bunch of other topics or other suppression systems that are introduced. If you cannot already meet at the cell level, the module level, or the unit level, then it becomes extremely complicated, extremely costly, because all of a sudden it's not just your battery module anymore. It's pretty much an entire electrical room with all kinds of safety things. And with the automotive NMC or NCA or NMA, it's very, very challenging to comply with those performance criteria tests on the cell, module, and unit level. That's why you have these big systems, or you see the big systems have all these prevention methods built in, and of course are much more expensive. With lithium iron phosphate, the thermal runaway is still there, but a lot less violent than with an NMA or NMC chemistry. That's why most manufacturers, I would say almost all except LG, is using lithium iron phosphate for residential battery storage systems. Palantech, one of the first manufacturers besides BYD to use lithium iron phosphate on a large scale, but most other manufacturers these days use LFP because of exactly that reason. You will never be able to have a cost-competitive product that fulfills the criteria if you use other cell chemistries. The key takeaway is the UL 9540 is a system certification. The 9540A is the underlying fire testing. And unfortunately, there's no lithium iron chemistry cell that fulfills those very hard fire and performance criteria of the UL 9540A as written in the code right now. And most battery systems, as already said, pass by putting multiple cells in a module and then multiple modules in a system. And the easiest chemistry is lithium iron phosphate because it's the lowest energy release in the thermal runaway. And now the most interesting part of the presentation is what effect has all of that to the Canadian market and the code? And it's really complicated. That's the main message, and it's a pain in the butt. If you read the code as it's written right now, you can literally not put any battery storage system in-house. Not possible. But there are some options and some deviations, and in different provinces where you have some ways around that you can still do it, or you don't put it in your dwelling directly. There are some rules that you can actually put it in an attached garage, for example, or detached garage, where the risk to the actual dwelling is a little bit lower. So the most critical part is that section 64.900, more specifically the 64.918. And let's go through it, what the code actually requires. So it needs to be marked suitable for use in residential dwellings where permitted. First thing is, no battery system currently on the market has that labeling because none of them is passing under that cell performance level criteria. Then the other thing is, cannot be below grade and cannot be on floors higher than 23 meters. So most people have space typically in their basement, but unfortunately that is, if we read the code, off the radar. The energy storage systems cannot be larger than 1 kilowatt hour. So 1 kilowatt hour is extremely small, so that's pretty useless for a stationary system. It's fine for your UPS system, for your router and your internet and whatnot, because that's typically a few hundred watt hours. But for a real battery backup system or energy storage systems grid height, you typically talk about 10, 15, 20 kilowatt hours for the average household.
So it's saying it can't be over than 1 kilowatt hour?
That's what the code says. And that doesn't make any sense. Exactly. But that's what's written right now, and that's where it's so difficult. And we will talk about what the options are in BC or in Ontario with those deviation options to still install battery storage systems in dwellings. Then it can be permitted to be installed in garages, as I mentioned, detached or attached to the dwelling. You have certain capacity limits at that point. If the structure or the garage is completely detached with a minimum distance of 1 meter, you can even do more capacity. So in that case, it's up to 80 kilowatt hours. And then the hardest one, that is that this equipment meets the cell level performance criteria of UL 9540A, which does not exist in the industry. And then you can actually exceed the capacity limits here. So we have a lot of restrictions, and it's pretty much impossible, as it's written right now, to do anything. Huge problem. And it's all about the poor wording when it was actually implemented in the 2021 code. There are some rewording efforts in the 2024 code, and yeah, we will see how that will affect future installations, and it gets a little bit easier. The good news is that there are 2 bulletins available. The ESA in Ontario brought out 2 bulletins, the 64.7, 64.8, that clarify what you actually can do, even though the code says that you cannot do it. And then, luckily for BC, there's also a installation bulletin, the 2306, that came out that also has certain requirements for the installation of battery storage systems in residential dwellings. Again, on top one, I have always the references to these codes because there are some nuances between those 2 options. So the general thing is you have 2 options. You have a system that is fully certified to UL 9540, and the battery is tested to UL 9540A, and you have the 2 marking suitable for use in residential dwellings were permitted, and this equipment meets the cell level performance. Unfortunately, as I said, the first option the code would allow you does not exist as a product you can buy today. So you have to go to the second option. And if you would have that, you can pretty much install it anywhere. But we don't have that, so we have to go to the second one where we, where we still have the certification, but we do not have the compliance test for the cell level performance, and we don't have that suitable for use in residential dwellings on the type label. And then you can install it in the non-living or non-habitable areas of a dwelling. Typically, that's a utility room or the garage, as I mentioned earlier, as the most suitable place for these kind of systems. When we want to install it in a dwelling, then there are certain deviation request options, either to in the Bulletin 64.8 or under the BC of Technical Safety BC, that Bulletin 2306. If the room where you install the ESS does not open directly into a sleeping area, then you can actually install that in a utility room, for example, or even a basement, actually. The room has a fire rating of minimum 1 hour, so typically that's double plywood, drywall, and you have to have an interconnected fire alarm system with some fire alarms on different levels of the building or different rooms, that if something happens to that room where the system is placed, that other fire alarms are also going off. And you have limitations that individual certified systems in its cabinet cannot exceed 20 kilowatt hours. And if you have multiple of them, let's say a larger customer wants to have more capacity, then you have a 20 kilowatt increment, certain separation distance, and another 20 kilowatt increment, up to a total of 40 kilowatt hours for the entire building. Or if the manufacturer has done the fire propagation testing with the cabinets side by side, so not the 1 meter in between, then you can actually line them up to whatever the specifications of the manufacturer is. And for Ontario specifically, that doesn't apply to BC, you have to have a minimum distance to egress windows or doors of minimum 1 meter. And if you have all of that, then you can even install it in a dwelling or even below grade, which is actually quite decent because now we have a way where even the code is written very poorly, there's still an avenue to sell systems to customers and actually install them and pass inspection. It gets easier if you actually put it in a detached or attached garage. The funny thing is most building codes, when they talk about a detached garage, it doesn't need to be fully detached. It can actually be a garage within the house. But from a fire safety perspective, the rating, it's still considered detached. Same thing applies. You have 20 kilowatt hours in one system. You cannot exceed 80 kilowatt hours now because you're now under the detached portion of it. Same distance requirements of 1 meter or what the manufacturer says. And that is my recommendation in general. If the customer has a garage available, that is probably the best spot to put it because that's the highest likelihood to convince your inspector that you met all these requirements and you don't have to go into designing the room to be fire rated and have the smoke alarm and fire alarm interlinked and all these little hoops to jump. That's just the best way forward. And sometimes that's available, sometimes it's not. If a customer has a townhouse and there is no garage and no real space, then of course it gets more and more difficult to place those systems. And then we have another option, and that's if it's available the best. For example, it's a farm and they have a little garage that's completely detached. Then you can pretty much do whatever you like. You can do the 20 kilowatts in one system, the same requirements, 40 kilowatt hours for multiple systems, the same spacing requirements, and you can actually exceed the 40 kilowatt hours and go all the way up to 80 kilowatt hours as the maximum capacity of that system. Again, if you have that, that's the best spot to install it. The approval requirements for Ontario, and that's slightly different than BC, if we sum that up, ideally the system is UL 9540 and UL 9540A certified and tested in the first place because that gives you all the documentation that you can hand over to your inspector and you're already 90% there. Versus if you have these field assemble systems, there's a lot more paperwork and you might be forced into a field evaluation and things get complicated and costly very, very quickly. The field evaluation, I put that in gray because that's something I would not necessarily recommend because it's just a lot more difficult. And the other option is you can still do lead-acid batteries under both the directives of that Bulletin 64.7 or the BC Bulletin, even though lead-acid batteries are, at the moment at least, do not have an equivalent testing method to UL 9540A as lithium batteries have. UL is working on that to define a test standard that you can also test chemistries that are not lithium, but until that is out, the deviation option and the variance request can be done that you can use a standard old-fashioned lead-acid battery like a flooded lead acid or HEM or whatever system it is. At that point, all individual parts need to be approved. So instead of a system certification, you have to have a certified inverter, a certified rack or certified transfer switch, and then you put that all together. And then the wiring and everything has to be according to code in your specific jurisdiction, and your inspector will go through the single components to then say, okay, I follow the second variance that is offered with that lead acid chemistry. And that is the main message. A lot of provinces have issues. On the East Coast, for example, you can not do anything right now, really. And with those two bulletins in BC and Ontario, they give you a way to actually install it. We will probably see that other jurisdictions adopt a very similar wording than what Ontario already has to make it also easier in Alberta or in the rest of the country to install these systems. The key takeaway here is, if you can, pick a system that is UL 9540 certified. And unfortunately, a lot of manufacturers have some certification to the old code, that was the 2016 version of the code, where they could issue documentation that was for each component separately. But unfortunately, that is not what's accepted under the 2021 CEC code. So make sure if you look at documents from any manufacturer that they actually have the 2020 version in addition to, because that's a very small detail, but it's a very big difference in getting your system through inspection or not. And the documentation needs to list all components. So some documentations on the market only list the battery and all kinds of whatever battery variants. but the inverter is missing, or the cabinet is missing, or wiring instructions are missing, and parts that are being used. And then you also are not compliant because it's not a system at that point. It's just a documentation for one component. And as we learned, a system certification is the entire system and not just one component. That is exactly what I just said. Make sure you have the testing documentation available, because a lot of manufacturers also are not fully up to speed yet. And they have some documentation, but not others. And for systems we supply, we are very, very hard on the manufacturers to deliver actually all the documentation that is needed. And it takes a very long time to get stuff, and it's difficult, but we have now, for the systems I will talk about later, that documentation ready that we can send you, and you have pretty much the entire documentation package that you hand over to your inspector. As didn't mention any manufacturers, but it's a new requirement, and it's new in the industry. Pretty much every manufacturer we carry in the industry is struggling with that because it's so new and it's so challenging to get certification and testing spots with the labs. They're overbooked for a few months, and everything takes a lot longer. And then, if you can install it in garages or detached or attached garages, if you have that possibility, because again, it makes it so much easier to pass inspection. And then, a lot of people also forget that. Similar to the disconnect switch on a grid-tied solar system, a battery system needs its own dedicated disconnect switch. And that is in section 6460 and 74, where it's pretty much the exact same as the solar inverter, just another dedicated one for your battery storage inverter. If you do have a hybrid system, then that hybrid disconnect in some jurisdiction can be the same as the solar inverter, because now battery storage and solar is in one unit, having the same disconnect switch. Some jurisdictions also require a battery DC disconnect in addition to the disconnect that comes into, or in most enclosures. So you have pretty much a lot of additional equipment to install under those rules. The interesting part is here what's available on the market, and the pretty bad thing here is that suitable for use in residential dwellings or dwelling units were permitted, that you have it marked on the battery storage system, and this equipment meets the cell level performance criteria of UL 9540A. None of the systems that are on the market right now have that labeling because they didn't pass. However, they pass, most of them at least, to the UL 9540 and UL 9540A if you have a certain combination of inverter plus battery. And specifically challenging is if you have multiple vendors in your system. So you have the inverter from one manufacturer and the battery from another manufacturer, versus if you have a complete system that comes from one manufacturer, because typically it's a sort of blame game. Who is doing the certification? Who is going to pay for the certification? And most manufacturers just push the responsibility to each other, and it takes a lot longer, versus if it's like a fully integrated system like a Tesla or a CSI or Growbot or other brands, then it's the same manufacturer that provides the inverter, the cabinet, the battery system, and they are only themselves to blame if they don't have the right certification. So that makes it a little bit easier. Just as a quick going through Schneider and on the 48-volt side, lead-acid battery can do full home backup, but cannot have the UL 9540 because the standard for lead-acid doesn't exist at the moment. Tesla Powerwall got the certification probably a year and a half ago, so they are full compliant for full home backup. You can do that. You have the certification for the system and the fire propagation testing. The SMA system will be fully certified with the BYD battery. SolarEdge with their new BUT 10, not the LG, only their own battery, is UL 9540 and UL 9540A. Iguana out of Calgary, or now Duracell, they have the certification. Schneider Pylontech, which we can see also in your cabinet for our vote. That combination is UL 9540A and 9540 certified, very, very popular. The SMA system for off-grid does not have it because that is still, the battery has the UL 9540A, but not the system. Solarc is popular in some provinces together with HomeGrid. That is fully certified. With Simplify, it's only certified to that 2016 code I mentioned earlier, so it's technically not certified. Fortress has, I see your mouse. Fortress has an option with Solarc. The CSI is a complete closed ecosystem from Canadian Solar. The GrowWatt with the GrowWatt hybrid inverter and the GrowWatt APX battery is also an integrated system that is fully certified. And then Ginglong Solis with the S6 and the PylonTech Force H1, that is also a system that is fully certified to UL 9540.
And also has UL 9540.
With Solarc, exactly, yeah. This is just a high-level overview. There are a few more, and pretty much every second week there's a new manufacturer that finally has now their paperwork together. And this is a work in progress. I just updated it 2 days ago with some more research of some of them, because the list a few months ago looked very different and we had a lot more red X's. So slowly but surely the industry is coming up to speed, understand the requirements, and have the documentation ready that USD installer need to be, to have a smooth installation and certification process. Thanks so much for that, and I'm happy to jump into questions if there are some, and have a little discussion. It's a very dry topic, typically, code stuff, but it's such a pain for a lot of installers that I think it's a very good basis to understand where it comes from and to really look for the right documentation that makes it easy for your sales and then, of course, the installation. Go ahead, yeah.
I didn't see Fronius on that list. Is there a reason why?
Because Fronius does not have a hybrid inverter at the moment. So in the future, once the Fronius hybrid will come to market, and probably Harsha has more information than I do.
It's probably going to be the next summer.
Exactly. That system will then also have a high voltage battery. There are some vendors that are already compatible with the European product from Fronius. We assume that is very similar to what the application will be in the combination in North America. The good news is that battery system already has UL 9540A. So the Fronius system, Fronius hybrid inverter plus that battery system will also have UL 9540 system certification. Yeah.
Just a quick question. What do you feel about a high voltage battery and a low voltage battery?
So we see a shift in the industry, specifically for North America. Most manufacturers came from a low voltage application, typically 48 volts, because all the inverters that were already certified and on the market and people knew, from the Schneider Electrics to the Outbacks to whichever brand you look at, it's all low voltage, because the code just until recently had a 50 volt battery limit. And now that battery voltage limit is now increased for residential dwellings to 600. So that was the initial issue, that you could not have a high voltage battery in your residential dwelling. So now the battery voltage is similar to the residential PV voltage at 600 volt DC, that you can also have a 600 or up to 600 volt DC battery system in your house. Looking forward into hybrid inverters specifically, and from a current perspective and from a cost perspective, lower current, smaller conductors systems are always easier to install, more cost effective than the 4-aught conductors and large bus bars and 250 amp breaker system and everything. That just adds a lot of cost, versus if I can have a wire gauge 10 RPVU cable for my battery system, or maybe a wire gauge 8, depending on how big the battery system is. It's just a lot easier to run, a lot more cost effective when you have these high voltage systems. And that's where we see in Europe already, I would say high voltage systems are probably 95% market share. And we will see the same direction. So every new product that is coming to, almost every new product that's coming to market is typically a high voltage system, because it's so much easier, so much more cost effective, and easier to scale. And also cost savings on the inverter side, because a high input current inverter, typically with a transformer, is more costly to design than if you're already on the high voltage level, where you can feed your DC from the battery directly on the DC bus of the hybrid inverter. It's pretty much just another string. Of course, it's bidirectional, but it's being treated as another string on the inverter, which makes it very, very cost effective.
Thank you.
Harsha.
A lot of the storage already exists in the off-grid market. Now, in terms of these requirements, you want to keep your storage size under 1 kilowatt hour, or units of 20 and not greater than 18. Are there any similar restrictions from the off-grid market? Because that seems to be a lot bigger.
Exactly. Yeah. So the code doesn't differentiate between an off-grid dwelling or a dwelling. A dwelling is a dwelling under the code. There's no difference. Of course, what a lot of customers do, especially the DIY industry, they don't necessarily get their system inspected. They buy something from Amazon, and probably there's never any documentation requirement or anything like that. And that's what we see. A lot of products are on the market that are not certified at all or not certified to the right element, but that's not necessarily what you as a professional solar installer, when you sell your system, are selling to your customer, because you are liable for what you install, you have the inspection, and it's falling back on you what you do and what you not do. So looking from that perspective, we will still see products being available for that off-grid segment, typically in the low voltage range. But once we go into newer products, hybrids, these all-in-one systems that are just very easy to install typically and very scalable, then we see high voltage going forward, just because of the cost. Yeah.
And do you see any sort of pushback from the industry? For example, in Ontario, you don't need to be a licensed electrician to wire your own house. You can wire it yourself, but you need to get it inspected. Exactly.
And it's not about who does the work technically, as long as you have your, in this case, ESA inspection, which you can file technically for you on your own. It can be a company, it can be your own installation. Typically, it's very challenging for DIYs installations to meet all these requirements, because most solar installers that install off-grid systems or battery systems already have issues with the new code. So chances are you have a lot of challenges, especially if you buy stuff from some online shops that put some kits together and it may or may not work in your jurisdiction when you want to have it installed, or may not be fully compatible to the insurance requirements your building has. Exactly. So from an industry perspective, battery storage is today at where solar installation were probably 10, 15 years ago. 10, 15 years ago, if you installed a grid-tied system, the inspector probably has never seen a grid-tied system before. When I installed the first system in Ontario and had the inspection, we did a DIY installation at a point, the inspector literally had to be walked through every single component. And after we walked through and said, okay, we have a string inverter, the question was, do you have microinverters on the roof? No, we don't, because I just told you this is the system we have with a string inverter. Because there was just no understanding. It was his system, it's the first system he ever saw. And going forward with battery storage, we have now a lot more documentation. The industry is more mature, specifically on the solar side. But it will also take multiple years until every inspector with all the bulletins and the code wording really understands what the requirements are for a smooth inspection and certification. Yeah.
What are you seeing on the cost side when it comes to battery storage, specifically lithium-ion? What's kind of happening?
It's a very, very good question, Danny. It's about cost of the systems over the last probably few years and what we see today. So that's actually super interesting. So in Europe, we already saw that cost decrease over the last few years, probably about 15-20% a year. So a massive reduction in cost. Over the last 2 years, with new players coming into the Canadian industry, also related to that now harmonized electrical code and certification requirement, we see a lot more competition. We see a lot more Chinese vendors that are already very strong in Australia, in the European market, in the Chinese market, also having their product available in North America. And that, of course, puts a lot of pressure on existing brand names, I would say, or older American manufacturers. And the cost is pretty much cut in half from last year to this year. So with those new vendors and new products being available, it's literally insane how cheap battery storage can be. I don't want to say any specific pricing, but you can have a 10 kilowatt hour full home backup system below $10,000, well below $10,000 Canadian from a hardware perspective. That's the status we are in right now. And going forward with more vendors on the market and more competition, this is even going down further. So when you compare that to a lead acid system just a few years ago, lead acid systems, if it's not about temperature, if you exclude the super off-grid -40 rating where you can just not use lithium-ion chemistry, the industry is going pretty much entirely lithium-ion because it's easier to handle, more cost-effective, a lot longer life expectancy, and more scalable than an old-fashioned lead acid.
So when it comes to the cost of heating and cooling for us here in North America, a significant portion of the electricity consumption is from that cost. Do you see that playing a big role in the adoption of batteries? Because in Europe, their HVAC costs are a lot lower than ours because their buildings are a lot better insulated than ours.
And there is no HVAC for most homes. Exactly, yeah.
So do you see that playing a major role here? Because for us, heating in winters would be a significant cost.
A battery storage system, especially an electrical, so electricity storage or battery storage system, is not necessarily something that you would use for heating your home with a whatever heat pump. It's more about the electricity rate structure, where you can use the battery storage systems to have some effects for time of use, for example, peak shaving, the resilience components of it, especially if you're a single energy source, a household. When you're completely on electricity for running your house, running your heat pump or electric baseboard, then of course you're very exposed, versus if you have electricity for your home and maybe a natural gas supply, then you're a little bit less exposed because you have two sources. But the component for the, let's say, time of use, that is what we will see going forward. Most jurisdictions have some kind of time of use structure already. Some are more advanced than others. Some are dynamic or going to be dynamic shortly. And that's really where the value proposition on-grid battery storage comes from, where you can sell the customer the resiliency component that you say, okay, I'm concerned about an ice storm or the power being lost for whatever, how many hours. I allocate, let's say, $5,000 to that safety feature, that I have always power on my backup. And then maybe the customer is assigning, or you in the sales pitch assigns 10, 15, $20,000 on the arbitrage part, that you can sort of make some money back. It's not a real business case right now, if you look into the structure we have. Specifically since the peak rate and the off-peak rate are not really too far apart. But when you look into applications like California, PG&E, or in Hawaii, for example, where you have ridiculously high on-peak rates and still high off-peak rates, but you have a delta that is probably 50 cents Canadian, 60 cents Canadian. All of a sudden, using your battery storage system with an intelligent control to charge and discharge at certain times, that's where the effect comes from. And that's where the interest from homeowners that have a heat pump, for example, or an HVAC system consuming power over the summer, that's where the value proposition comes from. Yeah.
I just wanted to pick your brain because I do know that a lot of cities are going in with mandates to have all electric at home.
Exactly.
And in those situations, your heat, cost of heating or cooling will start eating into whatever savings you might stand to make
Exactly.
by gating the system by either peak shifting or load.
Exactly. But it's not load driven, it's rate structure driven typically. Yeah.
I have a question for the group. We're not from BC. I know you have tiered pricing here, not time of use pricing. Is there any talk at all about having a switch to time of use in BC?
Yes. Yeah. So it's going to be optional, like customers will have an option of choosing time of use, but BC Hydro has applied to the Utility Commission for that.
Yeah.
It's primarily for EV owners, so they can charge in the middle of the night. I've done the math, it doesn't, as you said, the economics for battery storage doesn't really make sense, but as you said, it could be an extra selling point for someone who's already considering batteries.
Yeah, that's what we have in Ontario too. It's always optional. There's the regulated price plan, and there's the normal time of use, and what they've recently started is the ultra low overnight rate, which is also targeted towards EV owners. I think it's like 2 cents.
2.8 cents a kilowatt hour plus delivery.
And then the on-peak is like 30 cents, right?
Exactly,
So,
yeah.
so you can then get a little bit of an arbitrage, and it doesn't necessarily pay or give you a good ROI, but now you can pay off some of that and get some money back, right?
The battery storage system is not just sitting there and waiting for a power outage and is doing nothing 99% of the time. You can actually use your cycle life, which is very good these days with lithium ion specifically, to give some value to the customer in a different way. Yeah.
I have one more question for you, Alex. There's been a lot of talk lately about EVs being used for battery backup in your homes. Personally, it kind of reminds me of like the Tesla shingles discussion, where everyone's like, oh, this is a really interesting thing, but it never really became mainstream. I don't know what your thoughts are on
It's definitely a very interesting topic to have the vehicle to grid or vehicle to home or whatever you want to call it. It can be pretty much for backup only or for continuous operation. The big challenge right now with the chemistries manufacturers are using in EVs is typically it's an NMC chemistry, where you do have relatively good life expectancy, a cycle life, but it's pretty much optimized for driving first. So when you look into a stationary battery system where you have, for example, let's say a cycle a day or something like that, just as an example, 10 years is 3,600 cycles. That is already significantly cutting into the aging and degradation of your car battery. So the trade-off is how much impact do you put on the life expectancy and the range of your electric vehicle when you're also using it as a stationary application. That's part one. That's why Tesla, for example, doesn't allow vehicle-to-grid application right now, and there's a pretty strict no to that option. However, when you combine new systems and it becomes a cost question, you can have a smaller stationary battery, let's say 10, 15 kilowatt hours. And if you drive whatever F-150 Lightning or maybe an F-150 hybrid that has this onboard generator, you can intelligently increase your effective capacity for a power outage by having the stationary, but you can plug in your car to extend. Let's say if you have an ice storm and instead of the power coming back after 5 or 6 hours, the power is still off after a day and a half or two. Then, of course, your local small battery system is not getting you too far, especially in the winter when you have very little solar radiation. And then that mobile asset, more or less, will extend your reach, how long you can make it through the system. At the end of the day, a DC coupled system on high voltage, like a vehicle to grid, is significantly more expensive than a system that is designed for a stationary. There are, I think Sunrun has an option in the US that can be bought, but just that system I think is $25,000 US dollars for 7.6 kilowatts or something like that to use that F-150. I'm not sure what the value proposition is, and the sales numbers are not very high because of that reason, because once you sell that system, it's probably a $50,000 Canadian installation for, just to connect your truck to the house. Maybe not many customers are going for that. Versus if you look into the stationary option with just, let's say, the truck as a secondary input, pretty much a generator, can be a generator that's gas driven or can be the truck itself, then you just have an RV outlet in your garage technically. And the RV outlet is significantly cheaper than any of the bidirectional 10 kilowatt or 7 kilowatt DC to DC stages. We're talking about probably $100 electrical material to install that versus probably $4,000 or $5,000 just for that interface. And we will see how that goes. But it hasn't caught up yet. It hasn't caught up in Europe, where most home solar systems are installed with the batteries these days. And they're not installed, by the way, that's maybe an interesting fact, not because the battery has any ROI. Pretty much the battery is a drag on your ROI of the solar system. So the solar system is financing and making the battery look better, or the battery is dragging down the economics of the solar system. But people still buy a battery system for that. I want to stick it to my hydro company. I want to be a little bit more resilient. I want to have control over my own power supply, specifically now in regards to Ukraine situation and tough natural gas supply topics. And with prices coming down, it becomes a decision that is not necessarily financially driven. It's something I want to have it. I want to show it to my neighbor. I want to have the app. And it becomes a discussion of, do I buy fancy aluminum rims for my car, for my winter tires? They also have no ROI. But people like to have nice rims on their car because it's nice to have. And that's a similar idea that is behind the decision making to put a smaller battery system in a residential home in Europe. We will probably see similar directions. But for North America, my feeling is that due to the fact that the grid is less reliable statistically than, for example, in Europe or in China, we will have more the resilience component that is interesting for customers to say, yeah, I have a solar system, I have a battery system, and I know if the grid goes down, I still can run my lights and my Wi-Fi can make a cup of coffee and my heating controller is still running that my house is warm. So that's the value proposition mainly at this point. Good. Thanks so much.
Okay, this is tall, and I don't want to adjust it. I'm just going to be on my tippy toes. All right, thank you so much, Alex, for the wonderful presentation. Next up on our agenda, we have Rocky and Wendell from Hoymiles giving us insight into opportunities in solar energy and solar storage in Canada's sustainable energy landscape. The presentation is going to highlight some of the influences on national climate strategies and IRA incentives on the solar sector, and it discusses important provincial incentives and examines the synergy between the solar energy and energy storage. So just to quickly introduce our speakers, we have Rocky here. He is the president and CEO of Hoymiles Power Electronics in the USA. And as CEO, he leads Hoymiles' North American operation in developing and delivering transformational and innovative renewable energy solutions in module-level power electronics. And joining him, we have Wendell Rager. I hope I said that right.
That's close, very close.
All right, that's good. Is the business development coordinator for Hoymiles. And since August 2021, Wendell has been working in partnership with Canadian customers and providing sales and support assistance in the delivery and renewables, in the delivery of renewable solutions. So please give a warm welcome to Rocky and Wendell, and they'll be doing this presentation. Spin your mic right there.
All right, let me adjust the mic a little bit. Well, thanks, Alex. It was a really informative and impressive presentation. I mean, even like right now, it's still a lot of information going through my mind, right? So digesting, processing, like I almost forgot what I'm going to present. So, and another thing is, I think just referring to Alex's presentation, it just kind of freshed up on my mind why distribution is so important to the solar industrial. Because a lot of people, they just think about distribution just as a middleman. They don't really put any value to the industrial. So from this presentation and this event, people, friends, new friends or old friends, you already can see the value, why all the factories would like to work with the distribution. Because they're not only spreading the knowledge or educating the clients, but they're also screening out the, I don't want to say bad guys, right? But protecting the consumer. So in the end of the day, they're making sure the products are up to the code and also economic to the end user, making sure it's an efficient solution to the market and to maintain a healthy market for the industrial. So I really appreciate and really proud to be part of this event. And also, this morning when Wendell and I we drove to this location, when we found out it's right in the university, it feels like back in school. And Professor Alex just made the perfect sense there, right? So the full course, I mean, there's a lot of information we are gonna have to talk with our internal engineering for do the improvements. So I'm pretty sure. I'm going to talk about a little bit about the background about the company and our operation in North America. And then later on, I'm going to hand over to my colleague, Wendell, who is our key account manager in Canadian market. So he's going to go through some product information, including our current product lines and moving forward, the products we're going to release to the market. And then as well as the battery and hybrid inverter solution. So just after listen to Alex's presentation, we'll see. We can chat after Alex, see if we can have some kind of collaboration in product development. So anyway, Hoymiles, who are we? The new kid around the block, right? So let me see. How can I use this, Alex? Or okay, yeah. So the contents of my presentation, first portion is the introduction of the company and a little bit of background about the programs we have in the Canadian market, right? So federal, provincial, and in the municipality levels. So I'm pretty sure most of you are familiar with those programs. I'm just gonna go through quick, probably some numbers. And then I'm just gonna have a window to go through the product section. So Hoymiles, actually, here's a short story. It started with our co-founders, our CEO, Dr. Yang Bo, and Dr. Zhao Yi, CEO, Dr. Zhao Yi. Those two actually came out from Zhejiang University, a university considered top 3 in China and top 40 globally. Our CEO, Dr. Yang Bo, used to teaching in the class as a professor, and our CTO, Dr. Zhao Yi, used to be doing research in the lab. So in 2008, those two developed a micro technology, we call MLPE, right? Module level power electronic. So they developed the technology, and in year 2012, our parent company called Hankai Group, a company used to do Schneider and ABB OEM. So that's in year 2012. That's the year money or capital made the technology, and that's the same year in Hoheimauser Incorporated. So you can see there's some facts and numbers, for the past 11 years in development from our side. So far right now, we already installed 1.85 million devices globally. And our estimated production capacities will reach to 5 million, including our Mexican production line. So right now, we're pretty confident to say we're number 2 in this category, in micro category. So, and also you can see we have more than 1,200 global experts, and average 100% more in sales increase. So a global reach. So you can see our footprint pretty much in all the major solar markets. So including American, South and North America, Europe, Asia, Australia, and Africa. So here, what's happening in Canada. So thanks to the effort and the support from Frankensolar, right? So with their support, we are actually, you can see that's in grid area. That's all the provinces and the territories so we covered. So 100%. So that's what's happening in states. So we're covering around 95, 96% of the market, or geographically, right? Yeah, that's only on systems being installed on our platform. So we have other 2 OEM partners, so they already expanded into the different markets. So that's why I said we're number 2 in this category right now, even though in states market we have a huge gap to fill. So 3 things we're really proud of. First of all, it's R&D, and the second one is manufacturing, and the last one is service. R&D, because the back support we have, because it's we are backed by a university, Zhejiang, which is a Zhejiang University. Most of our R&D team is acquired the talents from the university. So that made our one of the major components, factors why we keep our products so economic or affordable. That's because from the software and the economic talent acquisition, because that's one thing. And the second one is manufacturing, because the purchasing platform we have, so we can keep to get a sufficient or economic components from different aspects. So that's why both factors combined, we can make sure our products are so economic. And then service, that's something we're doing, we're developing, improving on a day-to-day basis. So right now we have our Canadian office, and also we have a US office. So just depending on the region, time zone, or holidays, we're making sure clients, it doesn't matter where you're from, so we always have someone available. So our commitment is we're trying to make 15 minutes response under 15 minutes for the emails. Phone calls, it's right away. It just depending on the workload, right? So far, we haven't really experienced a large work volume. So that's all thanks for the first 2 points, right? The R&D team and the manufacturing to provide a reliable product. So the programs here in Canada. So we already know the federal government already took the initiatives and allocating certain dollar amount to support the renewable industry, right? So and they have certain goals to meet. One is in 2030 and one is in 2050. So far we see, with collaboration, I'm really optimistic about this to reach it. So that's why we're in the business. And another thing is that people don't value the crowd here. They always think about the programs, the government, or factories, the technologies. They don't see the people here who's sitting here. We are actually the major force of pushing it for moving forward. So thanks, everybody. So there's a few things about the IRA, and that's more to the US side, right? But in Canada, we have our ITC for the commercial side. As you can see, we have three major categories. There's a net metering, greener homes, and the ITCs. And you can see either which categories applies to either residential, commercial, industrial. So in different provinces and the territories, right? So, and there's a certain capacity you have to meet in able to qualify for the programs. And then different provinces, right? The incentives that we have. So we've seen last year or this year, the East Coast maritime provinces has been a really strong market for using our products, and that's all because of the impact that the programs made. So some projections about moving forward for the growing rate. So I'm going to pass it on to my colleague Wendell for the next couple of sections related to the product. So, yeah, I'll switch to him.
Do you have any questions about Oilmas and the brand?
This is based on many years of experience with microinverters. So 2 questions, failure rate, and where's your support center located?
The failure rate is a really good question. From our annually reported failure rate, the status shows 0.16% in North America and 0.18% overall globally. That's our failure rate. So we've seen a slight difference between the products like the 1:1, 2:1, and 4:1 ratios. The 1:1 is the best. The 4:1 is slightly higher, but it's still, like I said, the 0.16%. That's the highest we have.
And then for your support center, where is that located?
Support center we have 2. One is in Alberta, in Canada. One is in Dallas, Texas. So we also have remote technicians in central states and east coast of the states. So right now, the only little shy part is the west coast. So if people work late here, they might not be able to get a hold of us because of the time difference there. But it's only about the last hour of the day. But so far, we've been doing really, really good, on catching up all the issues.
You talk about market share versus other microinverter companies in the U.S. as well as Canada.
The U.S., even though we covered 96% of the regions, right, geographically, but we still see a strong competition with the other 2 right, like the big brands, big companies, which are Enphase and SolarEdge. So we have a long way to go if we want to catch up with Enphase. But we have a few things in development. We will see next year. Probably we'll have a better result. So there's a big gap, for sure. Even though we say we're number 2, but still there's a long way to go.
So you're number 2 on the microinverters in the U.S.
Yeah.
So ahead of AP Systems.
Yeah. So another thing is we're trying to develop. We're kind of trying to position ourselves like more solution provider. So that's why we have our rapid shutdown and hybrid inverter battery, which Wendell can go through for briefly, because those are the new products. Even for us, we don't have a full detailed information out yet, but Wendell is going to go through it. So we have a DC technology, and also we have a micro, the AC technology. So if you look at around the market, we are probably the only one who have who can provide a mature technology in both aspects. So on the AC side, we just released our micro three-phase 208. So that will be another good product to the market. So that's why for moving forward to 2024, we're not only focused on the residential market, we're actually encroaching into a smaller commercial and industrial projects in the market.
Thank you, Rocky.
Thanks, Jim.
Wendell, take the floor.
It's good to be here today. I'm from Calgary. There's two reasons I like to be here today. One, meeting with you folks and the beautiful weather that's out there. And two, we stopped for coffee on the way in this morning. And I got a text message from my significant other in Calgary. And she sent me a picture and there was 3 inches of snow on the sidewalk and on the driveway. And she says, I have to shovel the snow. And I was very empathetic for about 5 seconds. And then I said to myself, well, I don't have to shovel the snow tonight. So it's something that I've been used to for years. And boy, anytime that I don't have to shovel snow, it's a great day. So she's shoveling the snow tonight, and I'll make sure I'll take her out for dinner when we get back. So as Rocky mentioned, I'm going to be talking about some of our microinverters. Everybody familiar with microinverters? And a little bit of our new product of our hybrid inverter. So pretty simple marketing slide. You know, when you're looking at your house, we have it all. We have the microinverter, we have the DTU, and we have our cloud monitoring app that everybody has access to. This is our microinverter. So I like the line there. It took me a while. It said the genius behind the PV module, and it actually is physically behind the PV module. So I can't. This is hard to say. So this is we're up to about 500 watts per channel, or on our quads and our duals and our singles. We're good for up to 670 watts. I've sold some of these to guys that are using 550s right now. Some of our folks have been using 480 bifacials, and the 2,000 watt inverter works great on something like that. Efficiency is 97.9%. We're just as high as everybody else, as if maybe a little bit higher. Sorry, this is really hard to see over here. Split phase and 3-phase. So for Christmas came early for me this year, because I've been working with many of our customers, and the one question they always ask is, when are you developing a 3-phase microinverter? And so Christmas came when this announcement came out about 2 months ago. And now I go back to our customers and say, listen, we have this 3-phase 208 volt microinverter, and it comes in 3 different sizes. So that's good to know. And it is IP67 rated, so it's pretty much good anywhere. These are our 3 specific product lines. This 4th one I'll talk about a little later. There's a little bit of an error on the top one. It says up to 2,000 watt output. It's actually only 1,500. So just a little mistake. That's our HM product line. It came out about 4 or 5 years ago. And we have various models within all of those, with the duals, the singles, and the quads. As I said, in our quads, we go up to 1,500 watts. Most of these are 60 volt with 15 amp. When we went to the HMS series, we realized that higher water modules require more voltage, more current. So what we've done is with the HMS product line, our biggest one now is 2,000 watts. So on our 2,000 watt burners, it's a 4-into-1, it's a quad. Most of these across the line are 65 volts with 25 amps. So they'll handle a lot of the bigger wattage modules you're seeing out there now, the higher wattage bifacials, things like that. Not a lot of change in size, still the same size as a piece of paper, pretty much, and a little heavier. But I talked about it here in the left corner, my Christmas present, which was the 3-phase 208 inverter. I think we'll be selling a lot of those next year, because we're already getting customers looking for some small commercial stuff, small industrial stuff. So I'm very happy to see that.
That's a 208?
That's a 208, yes. Yep. We've had we're not new to the 3-phase game. It's been in other markets, European, in different voltages. We finally got it certified at 208 here in Canada. That's why it's good. So, and the HMS module, I believe, and I don't know what this is. I'm pretty sure I know what it is. We're in some of our other countries, we're selling balcony inverters. So this is a little inverter you would put on a balcony. I believe you plug it directly into your AC socket, and there's solar right there. So I do not believe this is going to be available in Canada, but if one of you guys comes to me and says, listen, I've got 1,000 balconies I want to do, we can make it available in Canada.
Won't be code compliant.
No, it won't be code compliant. Actually, it might be, because it is in our catalog, and I haven't looked at it in depth, but I think it might be code compliant. I don't know. I doubt it.
People have tried to do that.
Yeah. These are our, oh, sorry. Was there any questions? No? This is our cabling system. The bottom one that you see here, we're coming out with very shortly. The top one is just our regular cabling system. It's got a connector and a cable, and then a connector and a cable. Our bottom one, we've made it a little bit more modular, for lack of a better term, where you're going to see T-connectors, you're going to see cables in between, and if you need to make an extension cable, for example, to jump in between inverters, you can get it in a 1 and a 2 and a 4 meter. You won't need to, one tool should be speeding things up, hopefully on installation by about 70%. This is probably going to be available, I would expect, mid next year, maybe sooner. Our old cables, we have tons of those, so please feel free, we'll sell them to you. Our data transfer unit, I like to call this the brains of the system. I think everybody's familiar with that. It's our gateway to our platform. We have it in 2 versions now. Actually, we have it in 4 versions, depending on the systems you want to buy. We have a sub 1G for our HMS series, and we have a 2.4G for our HM series. We went to sub 1G because theoretically, the longer the wavelength, the farther the travel. So we should theoretically the travel on a sub 1G HMS DTU should be farther than the 4G. Both of those are available in Wi-Fi and Ethernet, as well as 4G. Stability, high, flexible installation. It's like any wireless device nowadays. I think we all have multitudes of wireless devices in our houses, and you can put them anywhere pretty much. The nice thing about this is if you want to, you can connect it via Wi-Fi or via Ethernet as well. I'm an Ethernet kind of guy. I like connecting things via Ethernet because I know it's going to be there all the time. And we can upload module data in real time. This is our S-Miles cloud platform. That's what we call it, where all our inverters and report to. You could just read through this. There's nothing really out of the ordinary here than you're used to probably in a lot of other microinverter manufacturers. What I would like to do is just get to here and get to just some of the things that we can do, much like everybody else. We can see energy, we can see wattage, we can do monitor level monitoring, as well as remote troubleshooting. And that's the nice part about it, and I think probably everybody's familiar with that. Nowadays, we have devices that need firmware upgrades. Our DTU needs firmware upgrades. Sometimes our microinverters need firmware upgrades. Sometimes our phones need firmware upgrades. Everything needs a firmware upgrade now. So we can do that over the line. We can do it over the air, for lack of I guess it would be over the line. And our engineers will help you do that. You can give them a call. They'll determine whether it needs down rev and it needs a new firmware. This one is just basically going a little bit further on what we talked about, module level monitoring. Sorry guys, I can't see that. Troubleshooting, advanced troubleshooting. I can let you read that. I'm really having trouble seeing that. I'm over here, sorry about that, folks. And then can I just take this? Yeah, thank you. That's better there, thank you. Plug and play solution, external antenna, which is always good. Our first generation didn't have an external antenna, and it didn't work very well. We've changed that. Yeah, you can like any other platform, you can take it and monitor and make it look like your house, for lack of a better term. You can put pictures in there and all that kind of stuff. It's compliant with all the with all the codes for Canada. We just recently got the SB certification for all our inverters 4 months ago. And that was due to Alberta. They bumped up their certifications to SB, and we had actually gone ahead. We had done that about a month before that. We had finished, so we didn't see a lot of issues with that with our HMS product line. The HM product line took a little bit longer to get certified, but it's also at SB as well. Module level monitoring, natural rapid shutdown, of course. We're all familiar with that. They're small, size of a piece of paper. Again, our failure rates, 0.016% or whatever it is. And our warranty is 25 years. That's standard. There is no uplift to 35 years. It's just standard 25-year warranty. So we're competitive with Enphase on something like that. This is just a couple of our systems that we've installed. This one is in Nova Scotia. It used some of our old MI inverters, which were previous to the HM inverters, and it's still that one's still running today. I believe it's a Megatron tracker, 96 modules or something like that. It's huge. I'd like to go see it myself, to be honest. And then a gas station and a couple other places, 74K. Some rooftop stuff. We've got a couple systems. One in Ottawa that's doing 100K right now. That's probably one of our biggest ones in Canada. This is our energy storage solution. This is another Christmas present. Lots of the guys in Nova Scotia have been saying, when are you going to come up with a hybrid inverter? And I keep saying, soon, soon, soon. This one we released, it's probably 2 weeks ago, maybe a little bit longer. But we don't have pricing on it yet. I don't even have a lot of information on it. So if you want more information on this, maybe the best thing for you to do is come see me afterwards. I'll get your email address and I'll send you anything that I can. So we're going to offer it in 2 versions, a DC coupled version and an AC coupled version. So I like the AC coupled version because there's a lot of our customers that have invested in Hoyle Miles microinverters, and they don't have to throw them away. They can just go with an AC coupled system. Those that haven't, they can go with the DC coupled system. And these are this is the key components of our microinverters and our systems. There's the different sizes for our hybrid inverters, the hybrid and then the AC coupled. This was very new to me. This is an early Christmas present because I didn't know about the low voltage battery till about 2 days ago. I had heard something about it, but I didn't know much about it. So I have no information on that at all. But that's our low voltage battery that will now be selling along with our systems. Microinverters may be installed on the roof already, may not. You may be using an AC coupled system. We have a data stick. If you need rapid shutdown, you will need rapid shutdown for any of the DC coupled systems. We have 2 versions of the rapid shutdown, 2 module and 1 module, and they're SunSpec compliant. The smart meter for consumption grade monitoring, if you need that, that picture is actually wrong. That's a Chint meter. That Chint meter is not certified in Canada, so we end up using the watt node meter. And then the S-Miles cloud monitoring platform, again, included with all our systems. So this is our new, which one is this? This is the, sorry. Yeah, this is the this is one of the, this is the DC one. So again, efficiency, anything new here that you guys probably aren't aware of? Nothing new. And again, like I said, I don't have a lot of information on this yet. I will be getting more just since it's so new. But we're like I said, we're happy to deal with this. We're happy to have it, especially for Nova Scotia, Northern Alberta, Northern BC, Northern Saskatchewan, a lot of the places. I have a lot of customers that ask me, well, would you put battery backup in your house? And I say, well, the last time I flicked a switch and nothing happened is, I can't remember it. So in Calgary, for example, our grid is stable. But if you talk to people in Nova Scotia, their grid is not stable. So I believe we're gonna sell a lot of these into Nova Scotia, if we can get by all the certifications and rules and things like that, Alex. That's gonna be tough. Again, our new battery still comes in 5 and 10 kilowatt. Again, one-step, easy installation. It's a battery. And again, like I said, we don't even have data sheets on this yet. So I can definitely get some and send them to you. And our rapid shutdown solution, it is SunSpec compliant. Pretty much out 8 to 80 volts, PLC, plug and play. We've sold a few of those yet for off-grids. Off-grids, guys are using those with some Solarcs, things like that, and they seem to be working quite well. And what's a presentation without some kind of a moving graphic? So here, this is our AC coupled solution. We're going to be compatible with pretty much every inverter out there. Yeah. Yeah, and again, one of the things that we're working off-grid mode too, so you'll still be able to charge. So as Alice was talking about self-consumption and economic mode or time of use, you're going to be able to set your inverters to do that. So you'll be able to set them in either way, and you'll do that all on the SMILES platform as well. So whether it's a microinverter or a hybrid inverter, you'll use the same platform. You'll be able to check the status of your complete system on one screen, and get any errors, monitoring, troubleshooting, things like that. Again, just some of the functions of what the platform will do for you. It is available currently as a homeowner app and an installer app. So the installer has a little bit more permissions, for lack of a better term, to do things on the system. The homeowner basically can just monitor it, takes a look at it, prints reports, things like that. The installer can do a little bit more. On the installer app, you have enough to be dangerous, let's put it that way. And that's it. Did you have any questions? Sorry for we blasted through that. My apologies for not having a lot of information on our new products. That's going to be coming out very, very soon. And like I said, stop by, give me your email address, and I can send you anything you'd like. Yes, sir.
You have a quad inverter. Traditionally, cable management of leads has been an issue with quad inverters. How do you address that?
I like to blame it on the solar manufacturers, the module manufacturers. You know, I mean, it used to be so easy when the J boxes were all at one end. You know, wiring that stuff in was a simple thing. Now with them being all over the place, it's a lot more difficult. I'm not sure if it's the best solution in the world, but we do sell whips. So we do sell extensions with our systems if you need them. We sell them in 1 and 2 meters. So it's good to give guys that option. A lot of people don't think about that, but you at least have the option to get your whips from somebody, and you know Frankensolar sells them, and you can buy them anytime you want.
Yeah. So on top of that, we keep our connectors all under the same brand. So we're making sure all the connections are tight.
It's all MC.
Yeah, MC brand under the same brand.
Yeah. And we've been pushing you a year ago. I don't know if anything ever happened there, putting you on a spot here, but we've asked you if you could do longer leads on the quad or 2 of them. Is that something you're at all, is that something that may happen or not?
Yeah, probably not anytime soon.
Yeah.
Because of the engineering team took the consideration on the also has to run that to make it longer. It's not only on from product designing side, and also packaging, shipping, everything that you have to modify. So it's kind of like a system work.
Maybe next generation.
Yeah. We'll
Well, I'll ask the same question of the Longy guy.
About like a meter and 1.4 meters.
Yeah,
So
yeah.
should be enough for most of the micros, but for quads, yeah, like if you're looking at a typical roof, that could be.
Yeah, quads have always been difficult. I mean, the early AB Systems quads were nice, but the modules were all pretty standard, right? And everything was in the same spot. It was easy to connect up, but now with the J boxes everywhere, it just doesn't work that well.
Center now, but that's
Yeah.
because of the split cell modules.
Yeah,
They
yeah.
have to be there.
Yeah.
Which makes a lot of sense. Everyone likes the split cell modules because they get you an extra 10-15%
Yeah.
wattage, right? So
Well, and it's standardization is a nice thing, but there doesn't. I remember when I used to buy mobile phones from Nokia. Every time you bought a new Nokia phone, you got a new charger, and it was different than the old charger, and you could never use it. And some standardization in some of those areas would not be a bad idea. So, any other questions? Yes, sir.
Question from the module manufacturer.
Why can't you make your leads longer? No.
I do see that for all models of the inverter that are at a cap of 2,000 watts,
Mhm.
right? Even either it's quads or the doubles or the singles.
Mhm.
So with the modules, are technologies evolving? The watts are getting larger and larger.
Yep.
For example, Longi is going to have this new module at 54 cell at roughly 450 watt
Mhm.
module. Now that's barely on the edge, and it's going to be a bifacial module. So that's barely going to be on the edge for your quad. And so all the other models won't be really compatible with the quad option. Now quad option would be great for, make economic sense for installers or for, end users. Is increasing the size of the inverters overall would be an option?
Well, you can oversize the inverter. So we could go to 1.35, that's what the warranty states. We're actually looking at possibly going to 1.5. So on a 500 watt inverter, you can actually oversize that to much, much bigger. And so, yeah, there's no worries yet. It's more, I've seen issues with even some lower wattage inverters with higher current. And there's some with a lot of current, and they don't run even on our HM product line. Just the current is too high, especially when you start factoring in, or the voltage when you start factoring in minus 30 in Calgary, or minus 40 in Calgary. So that's the biggest concern, and I think we've addressed that with the HMS product line.
So the oversizing ratio DC to AC limit would be 1.3.
Like I said, our warranty says 1.35. But we're looking at actually modifying our warranty statement to show 1.5.
Alex, didn't we get a letter from Hormels on 1.5? Isn't that?
We already have a letter for
So
1.5.
we already have a 1.5.
So pretty much all the modules that we have today work with the input current limit, so the IOC limit, because that's the critical factor for
Yeah.
them or other manufacturers, not Hormels. And the other component is the VOC, for very low Canadian exposure, where 60 volt for some modules is not enough. That's why the 65 volt for the 1000 to 600 and the 2000 HMS comes in. So these two items combined are very good for the industry compared to what else on the market.
And that extra 5 volts makes a big difference. It's a huge difference, right?
Specifically for 78 cell.
Yeah. So if you're looking for big modules and inverters, the HMS product line is the one for you. And one thing I forgot to say, the HMT product line, which is our three-phase 208, it comes in 3 versions. Like our HMS, it'll come in a 1600 and an 1800 and a 2000. So we have multitudes of inverters. In the HMS product line, we probably have 10 different size inverters when we only need about 4. But we have 10, and I mean you have multitudes of choice, but maybe you don't need them. So
Yeah, they all work together as well, which is worth pointing out. So you can use a dual and a quad from the HMS series in one string. If that's kind of how your roof layout works. You don't have to just stick with one type.
you just can't mix and match the product lines.
Yes, you can't go HM
Yeah.
and HMS.
And also we are slowly discontinuing the HM, which is the previous generation, and Frankensolar already has the newest model.
We only carry the HMS.
Yeah.
Yes.
So how does that installer
based on that perspective, there are two things, right? One is the availability of the RMA product for the replacement. Another thing is how you warranty to 25 years. So for the first one, it's easy. As a factory, we always have a stock available for previous generation. Another thing is that because Holy Mouse is a global company, we have different product lines in different regions. So the HM in the other regions is still really strong. It's because North America will have higher standard. So we are intending to use the new products. So based on that perspective, the production lines are still producing the older model. It just we're discontinuing in North America. It doesn't mean like globally. If step back a little, then we always have a stocking available for replacement purpose, right? Then the next question, I guess, extended to how we keep our warranty. That's the two things. We can guarantee only by talking we will stay in the market forever. So we have to really put in action how we warrant or how we carry the warranty. So there is different ways. We are working with the third parties, like different insurance company. So something goes wrong, then there's always insurance in place. So that's one way. Another way is we're allocating fundings from our sales in a certain percentage. So we're basically creating our own pool for carrying on the warranty. That's regardless of the market movement up and down. We still have a guaranteed funding to support the program. And then lastly, I think we just needed to work with people like Frankensolar. We put in trust. They trust us, we trust them, and we are hoping the market trust the relationship too. We're backing up our product and the service, and then they'll help us to move the products at the front end. So I think in that combination, hopefully people in the market will recognize it or maybe be more confident to work with us.
And it's always been a problem, obviously, with inverter manufacturers changing product lines. If you go back, Enphase being an example. When I started in the industry in 2012, it was M190s that everyone used, right? Then they switched to M215s, and then what was it called? After IQ5, and then 6, 7, 8.
Different trunk cables, so it wasn't backwards compatible.
But they always have safety stock, right? That's kind of one of the things that's required. And then any manufacturer is only as good as what they're actually standing behind the product, right? Enphase has done a good job on that for sure. I think what we've seen so far from feedback with Holy Mouse has been really good. One of the reasons we've partnered with them is we had some of our partners that used their product where we didn't carry it, and the feedback has been phenomenal. And they pushed us, in Europe, but here as well in North America and Canada. Some customers that did a lot of projects, and feedback was really good, and they asked us to carry it. So that was kind of part of the thought.
So I think there's another alternative solution. Is if just in case, in the end of the day, we don't have a product available, then we can rely on the technology. Because of micro technology, you can mix and match a product at the system level. So let's say for extreme environment or a scenario, you got one inverter down, and then in the same string you have two inverters. Then maybe if we don't have any replacement, maybe we'll send you two inverters. You can replace those two inverters on the same string, right? So then it will give you more flexibility. It's not like if you're working with string inverters. Sorry, Fran, yes. So anyway, something goes wrong, you have to replace a new product, right? But with our product, you only certain devices. So it's not going to impact the other string. So that's the beauty of the technology.
Long term, typically, what Enphase did, they had the new generation IQ5, IQ6, IQ7 that has the same connector as the old M190. So even the old M190 was not produced anymore. They had a currently produced product that was mechanically or electromechanically compatible to the string design trunk in this case that you had. So you had something that was current status, currently produced, but backwards compatible to a product or an infrastructure that was built in 10 years ago. And that's the mystery software too. You're not continuing to produce 20 years after the fact the old products that don't happen. So always backups and backups.
We have MIs in stock if you need them. And they were 10 years ago. They're on a shelf. We've got a whole bunch of them sitting there just for warranty reasons too. Nobody has MIs anymore, I don't. Well, there's a few out there, but. Okay, thank you very much, gentlemen and ladies. Have a good day and have an early Christmas like I did.
We got some time here, right?
Oh, Wendell, your mic?
Oh, no, let him walk around with it. Everyone can hear what he's talking about.
Okay. Thank you so much, Wendell. Thank you so much, Rocky. So this is our final presentation before lunch. We have some water that just came, so if you guys are thirsty, please go get some. I know I am, so I'm gonna go get some. But in the meantime, the next step on our agenda is going to be battery-ready solutions for GrowWatt. Zach was unfortunately not able to be with us today. So instead of Zach, we will be having Mr. Alexander Wolf. Danny? And Danny coming to present on behalf of him. So please give a warm welcome to, which one was it? Oh, Danny Mueller.
I need this, right?
Yep. Clip it up really high.
That's good? Okay. We got the presentation, right? I don't have to go like. Cool. How do we go back and forth here? I gotta go. It doesn't do anything. Awesome. Okay, so we're going to do a presentation about GrowWatt and their hybrid solution, which is quite an interesting product for the Canadian market. I will do the presentation part about the company GrowWatt, who they are, and then Alex will get to talk specifically about the product and answer any questions you may have about them. We don't need that. Yeah, so yeah, their ecosystem, they have a, GrowWatt is a Chinese company. They have a PV inverter, residential PV inverter, storage component, so batteries. They have an EV charger that we carry as well, and then it's a whole smart energy management. Talk a little bit about the growth of GrowWatt. A little play on words there. They've grown quite a bit over the last 5-6 years to the point where they now are the -- residential inverter company in the world in number of installs. They have an annual inverter production capacity of 3.1 million inverters. They're active in 180 plus countries with over 5,500 employees. So quite a big company, which is really important when you choose a partner, right? That is going to be around for the long term, not just for the short term. So yeah, you can see global presence. That went really quickly there. Global presence, as you can see, they're active in every continent, right? So headquarters in Shenzhen, China. They have North American headquarters in LA. They have headquarters in Europe as well, Frankfurt, Rotterdam, Madrid, London. And as I mentioned before, global #1 inverter supplier, which is quite impressive. I don't know if any of you were down at RE Plus in Vegas in September, but it's quite an impressive booth. There are quite a few really interesting products beyond what we carry that we will see in the Canadian market in the short to medium term as well, on the residential side as well as on the commercial side, and on the storage side. I don't really need to go into too much of the history milestones, but just kind of know that they've started in 2012 and since then have become the #1 global inverter supplier. As far as our partnership, we are the exclusive distributor for GrowWatt in Canada. So we have an exclusive agreement with them that we started, when was it? Middle of this year, right? And there was another company that kind of repped them before, but didn't have too much success. They're not really a solar distributor per se. So I think we can add a lot to them and give them a little bit of a wider platform to have access to people like you guys. So you're aware of these products, right? Because that's really what matters is when there's good products, you guys need to be aware of it. And that's our job, to introduce you to those. We all know about global warming, so we don't need to go into that. I think that's, yeah, with that said, I think Alex is going to take over here to talk about their product portfolio.
Thank you very much, Danny, for the company introduction. I'll take over for the technical part of the presentation, and today we want to focus on pretty much the residential hybrid inverter Growbot has, which is called MinXH. And Hasin, here we go. And that's what the inverter looks like. It's pretty much designed as a high voltage battery 600 volt string inverter. Most of the inverters have 4 MPP trackers. So specifically the larger units, the 8.2, the 9 kilowatt, the 10, 11.4. So it's a very flexible input section of the MPP tracker. It looks quite nice. For probably one of the design differences, a lot of manufacturers in the old days had an aluminum housing because the inverter was relatively inefficient. So you needed to have a heat sink that was relatively large in order to dissipate the heat. The Growbot design is a multi-level switching topology, similar to what Solar Edge, for example, had and SMA has in a few products, which is significantly more efficient. Therefore, the power loss that goes into heat is smaller, and therefore they can use a housing that is now a plastic housing with an aluminum heatsink in the back that is actually quite small because the efficiency is pretty good. This makes the inverter very, very light, very easy to install because it's just 32 pounds for the smaller ones and 45 pounds. So with that bracket you mount to your studs or to the back plate, drywall or plywood piece, it's very easy to hang the unit. Everything is built in, so there's no monitoring cards you need to buy. There's no special rapid shutdown extra system. The transmitter is built in, like most of those newer hybrid products. That is really one inverter unit, whatever power class you buy. We go over the power classes that are available later on. But pretty much it's the inverter, later on the transfer switch, and the battery. There's no other components to that system. The system is fully NEMA 4X rated, so you can put it outside, you can put it inside, whichever way you like. The inverter itself automatically comes with a 10-year standard warranty that can be extended all the way up to 20 years. And with the configuration app, similar to other manufacturers, you get guided through these steps into commissioning systems. So if it's just an inverter that you use for a solar system only, no battery backup, the system will ask you, do you have a battery once you go through the commissioning process, and you say no, and then it's pretty much done. Versus if you have a battery system and backup, then there are more steps in that configuration process that you go through to commission the system. So it's very easy and designed with the installer in mind, that you don't have to switch between multiple setting pages, but you will be guided through what you want to do, including selecting set points, how much reserve capacity you want for backup, and all these kinds of features. Quite nice. We actually installed a test system a while ago in our warehouse to go through all that and understand the product, and it works quite well. Some of the features that are relatively unique is that the inverter has a very high peak current capability that is relatively rare for a transformer-less inverter. Because normally in the off-grid day and age, like a Schneider XW Pro, you had an output transformer, and the output transformer plus, of course, the power stage allowed for extremely high peak current that you can drive a sump pump or start a motor or compressor off your fridge or something like that. But this system, even though not having a transformer on the output, still has a very, very high inrush capability to start your home if the system is completely off, for example. As I mentioned, it has the SunSpec shutdown transmitter built in, AFCI is standard anyways, and for some units in the US, not for the Canadian units, there's also a revenue grade meter. We don't have that because Canada doesn't have any requirements for a specific measurement on the inverter itself. The 4 MPP trackers is a very flexible tool specifically for multi-orientation rooftops to design the system with a system that needs as little components as possible. So just the rapid shutdown devices, ideally no optimizers, to really focus on as little components as possible in the entire system. The certification part is extremely important, not only the certification we talked about from the battery side of things in the system, if you add batteries to it, but also now with the requirement, as Randall mentioned, to UL 1741 SA and SB. Some jurisdictions in the Canadian market, specifically Fortis in Alberta, is already requesting the SB certification, and we see slowly but surely most manufacturers to have SB available. Heumals with the HMS series was also one of the first candidates in the market offering SB, and we will see that requirement pretty much going through the provinces, and sooner or later all the provinces will require the SB certification. It also has the communication specification, also part of SB, the 2030.5. No utility company uses that profile. It's pretty much a communication profile where the utility company can implement some bidirectional communication with the inverter to see for higher penetration of solar in the grid. Now we are at probably single-digit percentage for most jurisdictions, but once more people have solar, it becomes more challenging for the grid, to have a stable grid and to provide fault right through situations and information for the utility company what is happening on that low distribution segment. And that interface is there to implement future grid management features. The AP Smart shutdown device, the SunSpec, is built in. In this case, it's a SunSpec transmitter which would be compliant and compatible with other SunSpec certified shutdown devices, like the ones from Heumals, for example, or other manufacturers. So it's a very, very easy, open system to use. The inverter itself is rated for -25 to -60 on the datasheet. We have a special document from GrowWatt that allows the installation in Canadian environments down to -40 with no impact on warranty. It's a fully passively cooled system, so there's no cooling fan on the outside anymore, like most older inverters that had a higher power loss and therefore more heat that has to be dissipated on the heatsink. So it's just a heatsink where the rising air cools the system with pure convection cooling, which also removes component that can fail over the course of the life of the system. There's only one small fan inside the cabinet, like most other manufacturers too, to make sure there are no hot spots in the housing itself. NEMA 4X, so it can be installed up to 100% humidity. That's pretty much standard all these days. And of course, you can install it inside or outside. One of the features GrowWatt is advertising that they can have a very, very low string voltage. So it can go all the way down to 50. This is the inverter that has the lowest starting voltage in the industry. That sounds like a big sales pitch, but with every transformerless inverter, the target is always to have the strings as long as possible, because that's where the system is efficient. That's where you have the boost converter not continuously boosting a very large voltage gap, and a 50-volt string is not really a string. It's just probably two modules effectively that are in series. That doesn't make a lot of sense to design, but electrically that can be used. So again, doesn't matter which brand it is. If you have a 600-volt string design that is allowed up to 600 volt, use string designs that are as high as possible for your jurisdiction, no matter if it's a Fronius inverter or an SMA inverter or a SunGrow or a GrowWatt or any other inverter, transformerless, try to keep the voltage as high as possible, specifically for the Canadian climate, where we have both extremes. We have very low temperatures where we are restricted by the string length we can actually do, and at the same time, we have relatively high summer temperatures where the effective MPP voltage under temperature can be low. So you do want to make sure that the operation voltage under those warm conditions is in a as high as possible state to have the best efficiency and the best string design, and of course the least amount of strings for your design. The power classes are quite wide, starting at 3.8 kilowatts on the small scale, up to 11.4 on the larger units. The most attractive products here are specifically the 9 kilowatt, the 10 kilowatt, and the 11.4 kilowatt. The smaller ones are still interesting, but I will quickly talk about why the 9 kilowatt is so interesting. When you look into a solar-only installation in the typical household and typical electrical install the customer has, they either have a 100 amp service with a 125 amp bus bar rating of the panel, that's very common, or they have a 200 amp service with a 200 amp bus bar. And with the load side connection these days, the bus bar rating in a residential dwelling is restricted by 125 times the bus bar rating, which means if we have a 200 amp service and a 200 amp bus bar rating, 200 amp bus bar rating multiplied by 1.25 gives us 250. We subtract the incoming service with 200, gives us a 50 amp breaker. With a breaker sizing factor of 0.8, that gives us 40 amps continuous output current. And 40 amps multiplied by 240 volts gives us exactly 9.6 kilowatts. And 9.6 kilowatts is not 10 kilowatts. So using a 10 kilowatt inverter would violate the breaker sizing or your bus bar rating if you put a bigger breaker in, which will force you to either change the electrical panel to a 225 amp or reduce the service size. Both of these options are not very smart to do because the customer doesn't get any value from upgrading the panel if he already has a panel. So by picking the 9 kilowatt unit, you're nicely below the 9.6 kilowatt limit. You don't have to spend any money on the electrical panel the customer has in most of the cases. And the production difference from a DC to AC ratio is very minimal for most systems if you use a 9 versus a 10. For Ontario, for example, we also have a 10 kilowatt limit when it comes to easy grid application without a so-called connection impact assessment. And for battery backup systems with the transfer switch, you're no longer connecting load side, you're connecting line side to the transfer switch. So the electrical panel size of the customer doesn't matter anymore because you're connecting in front of that. And at that point, the 10 kilowatt is the best option because you're right in that limit of 10 kilowatts. You have the biggest inverter you can without any specific applications. And even if the customer only can fit, let's say, 7 or 8 kilowatts DC on the roof, you would still pick the 10 kilowatt inverter with the battery system because in case of a power outage, the 10 kilowatt has the full capacity for backup versus if you just pick a, let's say, 6 or 5 kilowatt unit, then you're restricting also the application under the backup function. So since the price differences between these units is very, very small, most people just go for the 10 kilowatt or the 9 kilowatt depending on what they want to do because it's overall backup functionality in backup mode and the grid application when it's a normal grid-tied system, the best bang. The system is also rated for an extremely high DC to AC oversizing ratio, goes all the way up to 200%. And the reason for that is since you have a DC coupled system, you can, for example, as a 10 kilowatt for easy math, you can output 10 kilowatt continuous to the grid in a grid-tied application. And if you have excess power, that can be used at the same time to charge your batteries because everything is on the DC side, on the DC bus. 10 kilowatts to the grid, plus conversion efficiency, of course, so probably you need 10.25 or something from the DC, and all the excess power that is still available if the battery is not yet full can be charged up to 10 kilowatts roughly into the battery. So you're having a very, very high DC to AC ratio possibility. The short circuit current is at 16.9 right now. That is being updated as we speak to 20 amps, so you can even use higher capacity modules with larger cell these days, but that's in the making. And you have a pretty good efficiency in that this is the peak efficiency in this case, 98.4, but I think the average efficiency is also slightly below 98, so it's a very, very efficient multi-level system they have here. The system is designed to be fully modular, so most installers initially sell solar systems and not necessarily in the first step solar plus battery due to the impact of cost, and not every customer wants to have a battery on day one. But having a hybrid inverter, even though you're not using it on day one as a hybrid, gives you the flexibility to go back to that customer and say, 2 years later, do you want a battery or do you want to have backup? And that's specifically interesting when there was maybe an ice storm and a power outage where everyone has the direct impact of being without power for 3 days. We have customers specifically in the East Coast, as you mentioned, Rocky, where they were out of power for almost 2 weeks after the last storm, and they are willing to spend money because they know that waiting at the gas station for 6 hours to get your spot to fill up your cherry can is not fun. And with a system that is already a hybrid, you don't have to rip out any equipment. You just add the battery system and the transfer switch to give the customer that extra functionality. The battery system is also quite nice because it's a stackable system. So you have 2 components. You have the battery management system with all the contactors, all the wiring terminals, everything is built into one top unit. And then you have multiple battery modules that are stacked on a bottom tray. And each battery module is 5 kilowatt hours. And the interesting part here with the Growbot system is it's a native high voltage system, which means instead of having, let's say, a 48 volt or let's say a 50 volt for easy math, 50 volt module here, 50 volt module here, and 50 volt module here, that forms a 3 times 50, 150 volt system. Each battery on its own has its own DC to DC stage. So each battery module is already outputting 400 volts, which means that you can install a system, not that we would recommend that only has 5 kilowatt hours plus the BMS unit. And that would be the smallest increment. You can have 10, 15, 20, 25, and 30, so from 1 to 6 modules. And with the larger capacity in energy, you also scale the output power of the system. So if you only have 1 module, that's 2.5 kilowatt continuous, 4 kilowatt peak. If you have 2 modules, that gives you the 5 kilowatt continuous, 8 kilowatt peak. So our recommendation typically is for something like that, if a customer already wants to have full home backup, the 10 kilowatt hour increment is probably the smallest energy size you want to give the customer, because 5 kilowatt hours, even if it's low cost, doesn't give the customer a lot of value, because you have the same work with the disconnect switch and the transfer switch. You have the same work to install the battery, the same inspection, but then only giving the customer 5 kilowatt hours. That lasts maybe a couple of hours depending on or 3 or 4 hours depending on how high the loads are. That's very limiting, so 10 kilowatt is the smallest package we recommend. The average package actually is more in the 15 kilowatt hour range because the system, as I mentioned earlier, is extremely cost competitive. So compared to other manufacturers where another module is significantly more expensive, you can have a system that is very cost effective with the 10 or 15 from the start without even cheaping out on capacity. The LFP chemistry, to my previous presentation, is the chemistry of choice for most manufacturers, because that's the one that you can get relatively easily through fire propagation testing and get it certified. The same applies to Growbot. They picked the LFP chemistry as well because it has little runaway problematic and is maybe a little bit more cost effective also because it has no cobalt in it. And from an environmental perspective, if you have customers that are concerned about mining operations, if it doesn't have cobalt in it, you eliminate that problem altogether. As I mentioned, each increment has 5 kilowatt hours, goes all the way to 30. The system is UL 9540 certified up to 1 stack of 30. So typically you saw earlier on, the code talks about 20 kilowatt hour increments, or if it's certified and tested and documented by the manufacturer, it can be up to 40 kilowatt hours in a residential dwelling or 80 kilowatt hours total. In this case, the fire propagation testing was done in 1 increment up to 30. So you can have 1 stack without any spacing requirements to a second stack, for example, as long as you stay below the 40 or the 80 for separated. The depth of discharge is 90%. That's typically industry standard. So you use most of the capacity that's available, and it's fully UL 9540A. The presentation here says certified. That's the marketing team. As we know, it's not a certification, it's a testing. It can be installed technically outside. The product, as so many other products, is not specifically developed for the Canadian market, where very low ambient temperatures are the norm. So I would not recommend to put the system outside because these batteries are not self-heated. And for proper operation, specifically on the charging side, you need to make sure that the battery should be above 0 degrees. So you should not be exposed to freezing temperatures, otherwise the charge current will be extremely slow, and the value proposition for the customer to have a reasonable recharge rate is not there. With that topic that every battery module is on its own and has its own DC to DC stage, you have 2 or maybe 3 major advantages. Each module controls itself, and if you have, let's say, aging effects and degradation, one module might be more affected than another module, and the modules are adding power to the same DC bus, which means each module is only giving as much power and current as it can based on its degradation state, or based on its thermal state. If it's very hot, for example, then it will limit the output power on its own, versus another module is not as hot or didn't degrade as much, will just contribute more at that scale. It's also a very interesting part specifically for future upgradability, since you have a parallel configuration where every module feeds in on its higher DC voltage level. You can buy a system today with 2 modules, and 5 years down the road, the manufacturer is probably not using the same cells in the battery module they have today, because industry is growing, there's higher density, probably more capacity available, everything moves forward. But having the actual battery chemistry in the module separated by the DC to DC stage from the output, you can add a battery module 5 years later that is a different chemistry, and it would work pretty much exactly the same way without any effect on the existing battery modules, which you would not have when you have a conventional series connected high voltage system, because you need to have the same chemistry and the same voltage parameters and ideally the same capacity for that module going forward. It's similar to the analogy when you have a string design, you have an old 60 cell module at 250 watts. If you put a different module in the same string, it has an effect to that string. There are some tricks to do that, but it's not ideal for that string, and you will not be able to use that new high wattage of that new panel you put in 6 years later. So you're restricting that newest module that you put into that string, similar to a battery series connection. But in this case, with that parallel setup, it doesn't do that. And it's fully passively cooled, so the battery module with its surface area is just radiating into the room if it needs cooling, and the power stage on the side has a little heatsink under a little cover. So the DC to DC stage, consider it as a little mini optimizer for the battery, is cooled on the side. Exactly, and that's, I already jumped ahead with my part, that you can easily mix and match different packs based on that separation from the cell to the outside system. The function of the battery and how you can use it is not focused or specific for Growbot, but there are certain operation modes that you typically use a grid-tied battery system with. One of the big ones, not so much in Canada, is self-consumption. So for example, in a net billing environment where you get, for example, very little money when you feed into the grid, but the consumption cost taking power from the grid is relatively high, there's an incentive for the customer to use as much solar power as possible that they produce themselves, versus giving it away for, let's say, 6 or 8 cents into the grid. The Canadian market, with most of the provinces having net metering, it's not affected as much right now, but looking forward into the future, it will happen the same way as pretty much other countries, that the value of solar will go down, what the utility company is willing to pay, and the electricity prices are going up. So there is an incentive to self-consume and optimize the self-consumption, and that can be done by charging excess power over the course of the day. When your load is already covered, you have excess power available that you normally would feed into the grid. You first charge your batteries, and then you use that power towards the evening and at night to discharge your battery to offset what you then would consume from the grid, so you no longer consume that from the grid. That's the standard operation mode, for example, in all of Europe, and in Australia, because they have exactly that system where Electricity is relatively high when you buy it, and you get your whatever 8.5 euro cents when you feed it into the grid. So there's a huge incentive to look for yourself first in your interest, and then the excess power is given to the grid and to your neighbor. You can also do with the same setup a export control. An export control can be a zero feed-in, if it's all the way to zero, or it can be an export limitation to a certain power value. Since all of those systems with a battery system typically have a smart meter at your common point of coupling, you have the infrastructure already to implement all of those, let's say, smart control features for your system. And then time of use, as we discussed with Harsha earlier, if you optimize your power consumption for certain times where you use it or not consume from the grid, a battery can help to time shift that consumption and charge rate. In Ontario, as Danny mentioned, we have that 2.8 cent ultra low rate, and then the 34, 35 cents, whatever it is, for ultra high peak. It makes sense to not consume any power between 4 and 7 p.m. because that's where the hydro rate is the highest. So you want to make sure that your solar system ideally is producing, covering your base load, and your battery system is making sure that you're, in an ideal world, not consuming anything in that time, because that's where you got hit the most, or get hit the most. There are multiple methods how you can use it. As I mentioned earlier here, you can use a very, very high oversizing. For example, if up to 20 kilowatts of DC power can go to the inverter, or goes to the inverter, 10 can go all the way to the battery, and 10 kilowatts can go into or out of the inverter. In this case, we have an example for 5 kilowatts going to the loads that are currently drawing power, and the excess power, 10 minus 5, in this case also 5, will go to the grid, and you can get your credits or your net billing credits. There are multiple modes the system can be programmed to. In a zero export mode, you would just control that the meter detects, oh, I would be feeding in right now, but I don't want to feed in because zero consumption. Then the inverter will just be throttled to not output more on the AC side than the load is currently needing. Yeah. This is a cool feature, not necessarily for the Canadian market, but in the US it's super popular because in the US, solar installers install a system, and it typically takes quite a long time until the utility company is giving the final okay to really be grid interactive, so to feed into the grid. At that point, you can give the installer a pre-PTO mode, which means that you do the self-consumption and zero feed-in. So the customer still has all the benefit for the self-consumed energy being produced by the solar on the roof with the battery to assist, but they're not feeding into the grid until the utility company says, now we are ready, and here's the paperwork that you're officially allowed to connect to the grid. And then the installer in the US, for example, can go to the monitoring portal and actively change the system from a zero feed-in to the normal operation without even going to site. PV surplus is pretty much exactly that. So you would typically, in all scenarios, cover the customer's loads first, because that makes the most sense. That's the most efficient from a technical perspective as well as from an economical perspective. PV surplus means first the loads, second the battery, and third, if you still have excess, it goes to the grid. That's pretty much the standard application that you do. There's another option where you use the battery to assist the system when the PV production is larger than the grid battery discharging. Yeah, so the grid in this case will assist the load when you don't have enough solar power and you don't have enough capacity from your battery. Time of use is pretty much similar as we discussed. You, in an ideal world, consume the solar first because that doesn't need any storage losses. And then you use the battery and the grid, depending on the time, to supplement your load. And then that was actually the charge, charge first. So you first charge your battery, of course, either from solar or from the grid, depending on the time of use rate. And then the next part is you discharge your battery once you have the high rates on the grid to offset as much as you can. The Grobot system has in the EMS, and that's part of that configuration guide I mentioned earlier, that you get asked what do you want to do and which of those features you actually want to implement with your customer. And you can specify how low you want to discharge on a daily basis, how much reserved capacity is there for grid backup, that you're not discharging when the grid is still running, and then you're at 20%, and then a power outage happens. Then there's very little value to the customer because he's only living off the remaining 20% base, which will not last maybe over the entire night until the sun comes back up in the morning or the grid comes back, either or. And you can configure multiple time frames. That can be on a quarterly basis if you have a seasonal time of use rate. It can be on a weekly basis. It can be on a daily basis if you have a Monday to Friday work week, and then on the weekend you have a different rate structure. And then you specify the times when you have the low rates, when you have the high rates, and the system is automatically calculating when to use the charge and the discharge to optimize for best bang. That's pretty much exactly that. You want to discharge when the electricity is super high. You use the self-consumption while you have solar, and overnight when the power is very, very cheap, then you want to charge your system to be ready for the day. And there are multiple versions of it, how much focus you want to put on time of use versus how much focus you want to put on the actual self-consumption increase, where you want to use more of the solar that is produced over the day to charge versus using grid power to actually charge. Between those three components, as we mentioned, the inverter itself, the battery system, and the transfer switch, Grobot also has a smart EV charger that is part of that ecosystem that can also participate in when you use your power to charge the car. You can use an algorithm that picks the excess power from the solar system and uses it uses the car as a smart load, and that's exactly over that Thor charger. The Thor is available in 9.6 and 11.5 kilowatts. They call it 9 and 12. It's either a 40 amp system or a 48 amp 240 volt level 2 charger. It has a 7.6 meter, 25 feet cable to it. And it has a nice display where you can, if you like, see exactly how much power you're charging and how many kilowatt hours you put in your car, and have some feedback to the person in their garage to do that. There's also an option with an RFID tag where you can lock and unlock with a card. You can also lock and unlock the charging station from your phone. So a lot of the features most charging stations that are smart already have implemented. Grobot has that as well, plus the integration in the entire ecosystem of the battery storage as well. And that's a differentiator a little bit to the wall boxes and the Tesla chargers of this world, that you can use that also considering what your solar and battery system is doing, and not just plug it in and the system starts, or plug it in based on a time of use rate where you say the charger activates the car's internal charger at 9 p.m. because that's when your time of use, for example, rate is lower. Relatively cool product, looks very nice, has an LED stripe that goes up and down depending on its charging or not. So very, very easy way for the customer to see what's happening and the system is actually charging, compared to most chargers typically only have an LED thing, or maybe a little ring of LEDs to communicate with different colors. Having the display is definitely an additional feature for the tech-savvy people or the tinkerers, for the customers that want to see more than just a charger. It's compatible to pretty much any EV, including Tesla or the NACS. It does not currently have the Tesla plug. It's still the J1772 plug. But that will probably also change in the future once the Tesla-compatible charging ports are available, or more manufacturers are jumping on the bandwagon of NACS. There's also boost mode, where you can, as I mentioned earlier, you can use the solar power to charge your system, or use the battery to do so. And here, for example, between 16 or 4 p.m., the charger is actually following the excess production of the solar. So it's smart enough with the smart meter at a common point of coupling, so the customers main service entrance to not consume more than what the solar is bringing, but it will still be programmed that is full at, or needs to be full at, for example, here 10 p.m. Then the system will already detect, oh, no solar available anymore. I'm going back into my configuration to whatever power you configured to continue the charge until you have reached the time or set point of your car. That is more, again, for the advanced home user that is optimizing with their EV, where the power is coming from, is really aware of it. Most customers probably would not use such a feature because most customers are already a little bit overwhelmed with just the basic plug-in and maybe some time of use. So you want to make it as simple as possible by probably just giving them the charger, but still giving them the documentation and the app where they can see how much power am I using from my solar, how much power am I using from the grid, how much power is my car charger taking, so they have a good understanding where their consumption on a daily, weekly, monthly basis for the home goes. And now my Haseen, the clicky thingy doesn't work anymore. While Haseen is doing some technical troubleshooting on the computer, if you have any questions, or we can jump into that right now. Oh, maybe I forgot to say one thing. The transfer switch is actually quite nice because the transfer switch is a 200 amp transfer switch for full home backup. It has a 200 amp service entrance rated breaker built in, and is also marked, tested, and labeled as service entrance rated. So compared to a lot of other transfer switches you can buy, and most of them, you will just take your laptop and move it over.